In today's lesson, we are going to look at length, mass, and capacity. The objectives of our lesson are for you to be able to choose suitable units of measurement to estimate, calculate, and solve problems in everyday context. Also, you're supposed to understand everyday measurement systems. Be able to use everyday measurement systems to estimate, measure, and calculate. In today's lesson, we are going to look at a particular system of measurement called the metric system. Before we look at the metric system, let us look at the following. Objects have different physical properties. We've got the size, we have the weight, which is also known as mass, we have the volume, which is also known as capacity. The whole point of measurement is to help us to quantify all these properties, which means we must be able to express all these properties as a number. Without measuring, you cannot say someone is tall, you cannot say someone is short, or you cannot say something or an object or someone is heavy or light. No specific information is given without measurement. But through measurement, we are now able to say someone is maybe, let's say, 1.6 meters tall, or 2 meters tall, or someone weighs 50 kilograms or 150 kilograms. The whole point of measurements is to be able to quantify those properties, which means expressing them as a number. However, there is a catch to this. Unless you know what a centimeter represents or a kilogram represents, those measurements won't be helpful. Units of measurements are amounts that people invent and agree to use. So, you can agree to use anything to measure. Like, we can agree that in order to measure weight, let us use burgers for example. We can say Mr. Nyaweni weighs 5,000 burgers. Then we can also use, say, logs to measure height. We can say Njabulo's height is 10 logs. Sondo's height is 10 logs. However, there are problems to using such units. Pause the video and think of problems that can arise from using such units. You've probably guessed right. These units would be problematic because they are not consistent. That is why the units that we use are standardized, which means they match an official standard amount that can be measured over and over again to give the same result. Meaning, if I were to give you this pencil to measure using probably, say, centimeters, you should get the same results that I got when I used the very same units to measure this pencil. There are a lot of units used in different countries, but the popular units used are metric system. The official name is the International System of Units, or SI units for short. So now we're going to look at how to choose suitable units for measuring. Metric units are as follows. For length, we have millimeters. We also have centimeters, which can be denoted as or abbreviated as cm. We also have meters, which can be abbreviated as m. We also have kilometers, which can be abbreviated as km. For mass or weight, we have grams, which are abbreviated as g. We have kilogram, which is abbreviated as kg. We have a ton, which is abbreviated as a t. Under capacity or volume, we have a millimeter, which is abbreviated as ml. And we have a liter as well, which is abbreviated as L. For area, when you measure area, you always square the result. Meaning, if the area is in millimeters, it will be millimeters squared. If the area you're measuring is in centimeters, it will be centimeters squared. If the area you're measuring is in meters, it will be meters squared. If it is in kilometers, it will be kilometers squared. So for area, you always square the result. If you don't square the result, then it's not an area. For volume is always represented in cubes. Millimeter, cubes. If something is in cubes, it represents volume or capacity. Centimeter, cubes. Meter, cubed. Kilometer, cubed. As I mentioned earlier on, in order for you to be able to use these units of measurement, you must know what they represent. For example, 1 centimeter represents 10 millimeters. 100 centimeters represents 1 meter. 1,000 meters represents 1 kilometer. 1 meter represents 1,000 millimeters. Underweight, a gram or 1 gram represents 1,000 milligrams. 1 kg represents 1,000 grams. Capacity, 1 liter represents 1,000 milliliters. So it is very important to know what each unit represents. Let us look at the following examples. Which metric units would you use to measure the length of a football pitch, the area of a football pitch? Before you attempt these questions, it is good to have an idea or a picture of what a football pitch is. A football pitch looks like this. It has the length and it has a width. We know that a football pitch is approximately the same length as a 100-meter sprint track. So I would use meters to measure the length of a football pitch. The area of a football pitch, we know that area is length times width. If our length is in meters, then definitely our width is going to also be in meters, which gives us meters squared. M times M is equals to meters squared. So our area is going to be measured in meters squared. Zalika estimates the weight of an elephant to be 150 kilograms. Is this a realistic estimate? Give a reason for your answer. So, an average man or person weighs about 75 kilograms. 2 people, this would give us 150 kilograms. An elephant weighs more than 2 men, so her estimate is not realistic. A man stands next to a tree. He estimates that the height of the tree is 6 times his height. Work out an estimate of the height of the tree. So this man is standing next to a tree. We have our tree here. Here is the man. He estimates that the height of the tree is 6 times his height. We should work out an estimate of the height of the tree. We know that an average person is 1.7 meters tall. Since the height of the tree is 6 times his height, this means we're going to multiply the height of the man 6 times. So if we multiply the height of the man 6 times, let us see the result that we get. 7 times 6, 6 times 7, we get 42. Write the 2 down, we get 42. Write the 2 down, carry the 4. 6 times 1 is 6 plus 4, it is 10. Remember, there's a decimal point, bring down the decimal point. So we get 10.2. So the height of the tree is approximately 10.2 meters. Remember to always put the units